Part C, function h satisfies h of x is equal to k f prime of a of x for all x, where a and k are constants. And the Taylor series for h about x equals 0 is given by h of x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial, etc. And we are to find the values of a and k. One thing that you should notice immediately is that this function h of x equals the series given there is really the series for e to the x. And again, so this is another place which indicates that that's something they expect you to have memorized. Now, I'm going to start again by building something up here. And it goes this way. If f of x is equal to 6 e to the negative x over 3, then f prime of x would be negative 6 over 3 times e to the negative x over 3. Now, one mistake that you might make in this point here is it says that h of x is k times f prime of a of x, f prime of ax. And you might find f of ax first and then take the derivative of that. But that would be like saying that if we were given this notation, f prime of 3, that you might substitute 3 for x and then find the derivative. Well, if x is your only variable and you swap in 3 for x, you're going to get a constant, and the derivative of that will always be 0. So with this notation, f prime of something other than x means to find the derivative of f at x and then substitute and then evaluate that derivative at whatever is in parentheses there. So f prime of 3 means f prime of x evaluated at 3. In the same way, f prime of ax, f prime of ax means f prime of x evaluated at ax. Alright, so I hope that's clear. So we do want to find the first derivative of f, and then we want to substitute ax for x. And I hope that's clear. Then k times f prime of ax would then just multiply that all by k. Now you may wonder, why don't I simplify negative 6 over 3? I certainly could at any point. I'm just leaving the numbers there in case that I need to see them. But I could certainly do that. Now, what we know is that this whole thing, which is h of x, is equal to e to the x. So all we're saying then is that if you look at it, the coefficient of e, or what we're multiplying times e to the x, is really 1. And the coefficient of the exponent x is also 1. And so at this point, all we really need to do is to say that negative 6k over 3 is equal to 1. Or at this point, we could say negative 2k is equal to 1, and k is equal to negative 1/2. Then, since negative ax over 3 is really equal to 1x, then that means that negative a over 3 has to equal 1. And since that's the case, a is equal to negative 3. And that's really all that you have to do in this case here. Now, there may have been other ways of going about solving that, but however you go about it, this should be your answer there. Alright, so that solves problem part C of this, and we're done with this problem.